All right, I'm going to go over number 5. We didn't get a chance to do it in class. Hopefully this video will explain it well enough. So I'm going to get started right away with part A. It asks you to draw a free body diagram of the forces acting on the lawnmower. So in order for us to do this, we need to draw a dot. And we already know that the main force acting on every object is the force of gravity. And in addition, there is an applied force being applied by the person at a 45-degree angle. Even though the person's pushing down from above, it's acting on the object in this direction, and that's why I draw it in this format. Now, because it's on the ground, there is an upward force called the normal from the ground, and according to the problem, there is also some friction because the grass rubs against the lawnmower. There you go. Just drew a force diagram. Now, we're going to move on because part B is going to ask us now to make some calculations of what that frictional force is that we just drew. So the first thing you need to notice is the forces that friction is acting, the forces that include friction are acting in the x direction. And so what we have to do is we have to actually write a statement for the sum of the forces in the x direction. Now, you got to note that there is some of this applied force being applied in the x direction. It's a component of the applied force. It's the x component of the applied force. So I'm going to first write my statement showing you the forces acting in this direction. So force of friction minus this applied force in the x direction. And the way we make something the horizontal direction is we multiply it by the cosine of the angle that it's acting in. And then this all equals ma. This is my net force statement. However, what makes this problem a little easier is this is 0. So it's going to break down to f of f minus f of a cosine theta, terrible looking theta, equals 0. So therefore, the frictional force equals f of a cosine theta. And if I put some numbers in here, the f of a is 88 according to the question. The angle is 45. Make sure your calculator is in degrees mode, and you can calculate the force of friction. And I got roughly 62.2 newtons. Circle that. That is my answer. So what I'm going to do is I'm going to write this down somewhere because I need some space. So the force of friction is 62.2 newtons for B. All right, that wasn't so bad. So now we're going to erase all of this so we can work on part C. Done. C. This time we're being asked to calculate the normal force. Now, if I go back to that force diagram, you can see the normal force is acting in the vertical direction. And so therefore, I have to make a force statement that involves all the forces in the vertical direction. And the way we often refer to this vertical direction is all of the forces in the y direction. So you can look at it like this. The normal force pushing up, force of gravity is pulling down, but also the component of the applied force, which we'll multiply by sine because it's now the vertical component, is pushing down. This all totals ma. And as we said before, ma equals 0 because the acceleration is 0 in this direction. So then I could calculate the normal force by adding the other two forces to the other side. And further, in order to find the force of gravity, it's just mass times 9.8. We already know the applied force is 88, and we know the angle is 45 degrees. And if you do all of this math in a calculator in degrees mode, you should get something around 199 newtons. And I want to make a point, that's more than the object's weight. By pushing down on the lawnmower, you actually make the ground push back on the lawnmower more than its weight. So let's write this neatly here so we can do part D. Erase, erase. All right, part D. Now we want to actually give this lawnmower an acceleration. In order to do that, we've been given some information. So you know that it's going to start from rest, and you're going to eventually bring it to an actual final speed of 1.5 meters per second. And you're going to do all of this in the time of 2.5 seconds. So you're going to have to use a kinematic equation for this, and the one we'll use is VF equals V naught plus AT. So if I plug in all the numbers of 1.5, 0, my unknown, and 2.5, and then some algebra happens, I'm going to get that the acceleration is equal to roughly 0.6 meters per second squared. So that's the acceleration of the lawnmower. And now that I have that, I'm going to rewrite my statement for the forces and set them equal to MA, and this is going to become A. So I need some room, so we're going to erase all of our hard work. Write this A again. All right, here we go. Now I'm going to rewrite a statement that involves friction because it made a nice little mention of the fact that there is the same friction force. So the way we're going to do this is the person is now pushing the lawnmower with an applied force in the x direction. So therefore, we're going to use cosine of theta. And the force that is opposing the push is the force of friction. And all of this will equal to MA. So if I start throwing numbers in here that I know, this is 45 degrees. Friction was already answered up in part B, so I can just rewrite the 62.2. The mass is 14, and A is now 0.6 as we just previously calculated. So now I just got to do some algebra. And if you add and divide everything properly, you're going to get roughly 99.8 newtons. Now, I hope you're aware this statement was the forces in the x direction. That was this. And if you go back to the original force diagram, you see friction and the applied force times cosine are the forces acting in the direction of the x direction. Now, some of you are going to ask, well, why did you write the applied force portion first and friction second? And I had to do this subtracting because friction is the one opposing the motion, and the object is moving forward, so it's moving in the direction of the applied force. So you have to put the force that designates the direction of movement first in order to get an answer that makes sense. Anyways, I hope all of this made perfect sense, and now you're a complete and competent